Hi, in this session we are going to talk about how to reverse a doubly linked list. We have already seen in one of the videos that how do we reverse a singly linked list. In this video we'll talk about doubly linked list. So frankly, reversing a doubly linked list is pretty much easier than reversing a singly linked list, because in case of doubly we have access both to the previous pointer and the next pointer. So when I talk about reversing a list, reversing this doubly linked list, what we want is that if my initial list looks something like this, after the reversal it should look something like this. This points to null and this points to null. So one thing we understand pretty much is that if we just reverse the positions, which means that if we make the prev of 4 the next of 4, so basically now prevs should start acting as next and the next of a node should start acting as prev. Okay, so this is the only thing that we have to do. So let's say right now I have to just reverse 4 and 7, or let's say I have to just reverse the links of 4. Basically I want that prev of 4 should act as next and next of 4 should act as prev. So what we can do is, let's say I call 4 as current. So let's say I have a current node which is 4. For that what we'll do is we'll simply do current prev is equal to current next. Okay, so what we are doing is we are simply making the prev of current as the next of current. Okay, now what we have to do is we have to do current next is equal to previous of current, but as you can see that I have already changed current prev. So right now how my list looks like, let's say if this is 4, the prev already points to 7 and the next already points to 7, and the 7 prev we haven't touched that, and rest of the list looks similar. So right now as you can see that the prev of 4 is also pointing to 7. It's not pointing to the original prev. So we have to make sure that before we do this we have to store the prev somewhere. So let's say I have another variable prev in which I'll just store the current prev, original prev of current, okay, before I do things. So now this is going to be my prev. Now I can simply do the current next is equal to prev. So this changes this particular link. Okay, now this particular link starts pointing to null. Okay, so this is how it's going to be. Now I have done this for 4. I have changed the links of 4. I have to do the same thing for 7. So what I can do is I have to update my current now. So whosoever link we are changing, will keep that as current. So for that what we need to do is we need to do current is equal to, so let's see which of the link is actually pointing to current. So as you can see that the prev of 4 is actually pointing to 7 right now, because the next we have changed. I want you to understand this pretty well. I'll just make the link again. So now this is how it is. So I've just drawn the link. So this is the next of 4. This is prev of 4. So the next is pointing to null and the prev is pointing to 7. So what I'll do is I'll update my current to point to prev of current. So current right now is 4. So this is how things are going to be, and this is the same thing that we can do for all the nodes. So what we are going to do is we are going to run this until we get our current as null. So we will have a loop. So let's just write down this complete code once again and let's just dry run to see that whatever we have assumed is working fine or not. Okay, so we have written the code. Let's just run this code to see what happens. Okay, let's just dry run it, and this will also make your understanding of links changing very much better. So make sure you do this. Okay, so initially our prev is null, our current is 4, this is our current. Okay, and we do current prev equal to current next. So the prev of 4 starts pointing to 7. So let's say this is 7. As you can see that the prev of 7 is still pointing to 4. Okay, let me put this as prev and this is also prev. Okay, these are prev pointers. We'll just put p and n to understand things better. Current next equal to prev. So the next of current, which is 4, becomes null. Okay, this is how it is, and we have rest of the list as it is. We have the next of 7 pointing to 9. The prev of 9 is still pointing to 7. Okay, this is prev and this is next, and then we have 10. Okay, this is how my list looks now. Now what we do, we update our current equal to current prev. So now 7 becomes my current. So this is my current. Now what happens? Prev equal to current prev. So now my prev becomes 4. Okay. And then we have current prev equal to current next. Okay. So the prev of 7 becomes current next, which is 9. Okay. So now how things goes is, so now we have 7. The prev of 7 is now pointing to 9. Prev of 4 is 7. The next of 4 is null. Okay. The next of 7 is now going to change. Let's see what it will be. The next of 7 now becomes prev. So current next equal to prev, which is 4. So the next of 7 is 4. This is how it is. And current is equal to current prev. So now 9 becomes my current. Okay, this is my current. Just after these particular operations, how my list looks, this is how it looks. The next of 9 still points to 10. Let's say I keep it here. The next of 9 still points to 10, and the prev of 9 still points to 7. Okay, and also this is my current. And 10 prev points to 9, and 10 next points to null. This is the latest status of my linked list. Okay, now again what we do is prev is equal to current's prev. Okay, so what is current's prev? Current is 9, its prev is 7. So my prev becomes 7. Okay, after this what we do is current prev equal to current next. So the next of 9 is 10. So what we will do is, now my looks something like this. The prev of 9 is 10. Okay, current next equal to prev, and the next of 9 is 7. Okay, and this was already the link over there. 4 next was null, and then we have 10. Okay, now the 10 prev is still pointing to 9. Okay, and the 10 next is still pointing to null. Okay, this is how my thing looks. I update my current equal to current prev. So now 10 becomes my current. Again we store prev is 9, current prev equal to current next. So now what happens is that current prev, which is 9, is now current's next. So now we have current prev is equal to current next. So the next of current is null. So now our list looks something like this. Null, we have 10. Okay, we have current next equal to prev. Now the next of 10 is 9, and we already had this particular thing. So as you can see that our list has been updated. Okay, and now our current becomes current prev. So now my current becomes current prev, which is null. Okay, so this is how, as you can see, my list is changed. But there is a problem. So as we all know that there is always a head which points to the first node of the list. So initially my head must be pointing to 4, and it is still pointing to 4, but we have to take it and point to 10. How are we going to do that? So we have to update our head. So basically we want our head to point to 10. So if we see how we can access 10, so our prev is pointing to 9 right now. Our prev is pointing to 9. Current has already become null, so I can't use that. Our prev is pointing to 9, and 10 is the prev of 9. So what we can do is, we can simply do head is equal to prev. So basically we should have kept it previous. That would have been more easy for us to understand. So it will be like previous prev. Okay, so this is how it is going to be. Make sure you have necessary null checks. So let's say in this case, if we already have our previous as null, in that case if I do previous prev, that will give you runtime error. So simply check that if previous not equal to null. So this is how we are going to reverse a doubly linked list. Now let's just go ahead and write the code for it. Now let's just go ahead and write the code in Java, what we have seen till now. So we just saw a rough code that how the things are going to be implemented. So we saw a very rough implementation. Let's just write it down in Java and see that if my code is working fine. We'll run it and see that if the list is getting reversed or not. So we already have a DLL main. This is the main class from which we'll be calling all the methods of doubly linked list. And we have already written the code of inserting at beginning, end and stuffs. We have already seen that in previous sessions. So here we assume that we already have the head with us of a created linked list. We just have to reverse it. So let's just go ahead with creating the current and temp. So we'll have node temp is equal to null, and we'll have current pointing to head. Okay, we'll run a loop till current is not equal to null. The first thing that we had to do is we had to store the prev in temp. We update prev of current to point to next of current. So current dot prev is equal to current dot next. The next of current will point to prev, which we have stored in temp. And sorry, this is going to be next. And we are going to update our current. Current will be updated to current dot prev. Okay, this we have done. After this, after the loop is over, we just have to update our head to point to the first node of the reverse list. So we'll simply check that if temp is not equal to null, we'll simply do head is equal to temp dot prev. And in case, if you don't put this check, your code will run for some cases when we have like multiple nodes. But let's say if we have just one node, in that case this temp will become null, and if you try and access the prev of a null object, you will get runtime error or you'll get null pointer exception. So make sure while you're writing the code you have proper null checks. Okay, let's just run this and see if things are working fine. So for running that, we'll have to run this. So let's just do it. So we'll have to insert the number of nodes. Let's say it's 5. Then we put 1 2 3 4 5. So as you can see, this is the original list. So we once call print list before reversing, and then we call it after reversing. So our code works pretty much fine. Try and run it in more test cases and be assured that this is working fine, and make sure you're writing the code on your own as well.